Okay.
What? I feel like I would also learn.
She did.
Oh yeah?
Okay, what's the next one? Besides predator avoidance?
Maybe it's a ritual that they do before migration.
Okay, good. First of all, I also, let's see. Someone said communication.
To find food.
Mm-hmm. Oh, that's what it is. God, why isn't it letting me do this? Come on.
It's only for iPhone.
What?
What app is that you're using?
Everything. Explain everything.
I've never tried it, but I've seen other people. It's really cool.
There we go, finally. Okay. Someone said, what is it, migration?
Yeah, a ritual they do before migration.
Okay. Let's see, there was another one. Hunting. Okay. Any more?
Maybe some kind of meeting ritual.
Okay. Okay. Good. So, the question is, how would we test, let's say, the keep cool hypothesis? This takes observation.
So they do the similar behavior not over the water?
Okay, not over water. So you're saying, what's the difference between the overwater and our overwater?
Well, he was saying that
They keep cool.
he said, yeah, but he said like over the water, keep cool.
Okay, well, so, in other words, so maybe over the water it's cooler.
Yeah.
Okay.
Or maybe they like go into the water or something.
Okay. They also, it turns out, do this in really hot places too. Okay? So, the prediction would be that if it's really to keep cool, that it would only be when they're frozen, cold. Right? Or no, I mean when it's hot. Sorry, that's right. The other way around. So they do it no matter when it's cold or hot. In fact, up there, that's Humboldt County.
Yeah, that looks pretty cool.
It's actually winter up there, so it's cool. It's not terribly cool, but cool enough. Okay. Predator avoidance. How would you test that? Okay, you could take away predators.
Try to observe to see if the predator's actually around while they're doing
Mm-hmm.
display.
Right. Okay, that's good. Anything else that you might do? Remember, we want to try to actually,
Bring in the predators.
yeah, we want to disprove the predator avoidance hypothesis. So, how would we? It's hard to do a field experiment. It's pretty much observational.
Well, what if there was like a flock of birds that were just like hanging out,
Mm-hmm.
brought in a predator and see if they did it?
Yeah. Okay.
It'd be pretty messed up.
Good. Excellent. Yeah. It turns out this is a mixed flock of seabirds, shorebirds, like different sandpipers and whimperls and all sorts of different things. And they all hang out together, obviously on that rock. It seems like it's probably safer there, perhaps. This kind of behavior is found all over the place too. So it doesn't really matter whether, it can happen anywhere. So what you said, the prediction is that when predators are in the area, you'd expect them to do it more often. So you do an observational study and take as many individual measurements as possible. Like you go down there once a day, you see them do this behavior, do you see any predators or not? And then also, to get a little bit cleaner on it, they're all sitting there on this rock and you see like a peregrine falcon come in, and what happens, right? So this is kind of correlational, but it gives you some predictions that perhaps support that. If it was an anti-predator behavior, how are they accomplishing this?
They look bigger.
Mm-hmm. They look bigger. Anything else?
They could, should I talk or something?
What?
Should I say something or should I listen?
Go ahead.
They could, if a predator is coming towards them, they could all split up at the same time, and it would make it harder for the predator to decide who to go after.
Okay, so do they split up or do they stay together?
I mean, if a predator,
Yeah.
I didn't see any of predators.
Let's say a predator shows up.
They would split up under that theory.
In other words, each individual would go their own way.
Right.
Okay, good. Anything else? Would they, what do fish do when they school?
They stay in a really tight knit group.
Mm-hmm.
And if predators do come, they still stay in that area. But if whenever say dolphins come through,
Yeah.
they split into two groups and swim back around, and then they come into their
Okay.
shape again.
Okay, and so but there's still groups, right? Okay.
There's not really any individuals.
Right, yeah, and they stay in a tight formation when they're changing, just like these shorebirds do, as a matter of fact. How do you think they stay in such a tight formation? Is there a leader, do you think? Okay, perhaps. Is there not a leader? Could you get this behavior without a leader? No. Okay. Anybody think that maybe you could get this behavior without a leader? And how might it happen?
I think it's kind of like working together, like they all know what.
Okay. So this is a working together, cooperative hypothesis. Okay. So you don't need an individual leader, but everybody's kind of like a group mind.
It's kind of like, this is going with the predator avoidance. If like an individual is on its own, it's not as safe as like if you're within groups. So
they get a, right, in other words, so the predator, instead of splitting up, they stay together. And that's actually prevents a predator from going after them, because they're all in this group and flashing and all that, right?
Yeah.
Okay. Can you think of any mechanical way that they would not do it necessarily for cooperation? In other words, they're not really thinking about we have to cooperate here. They can maintain this kind of cohesive flock, just because of the properties of the flock. So think about if you're in a flock and you're surrounded by others, and they make shifting changes, like split second, faster than you could actually think about it. Okay, and they all do it in the same place. How would they actually accomplish that? Have you ever seen, the V formation with geese? Okay. Why do you have one in the front and then all these guys in the behind, kind of offset? What do you think they're doing there?
Is it for like aerodynamics?
Yeah. In what way?
They use less energy.
Less energy. Okay. And it turns out, when young geese, they're not so good at it, but they learn, and they don't learn, they learn by trial and error, or a little bit more than that. They feel change. It's like trailing a semi. So you've got this wind shadow, right? And you're having to spend less energy flapping. Hi. And just the littlest bit is less resistance than a little bit more. And that's what actually affects where they situate themselves. And so individuals now, the poor bum who's up at the front isn't getting the effect. So I forget how that works. But anyway, now in this flock thing, can you think of a similar mechanism where they feel all these other birds around them, and the slightest difference, they all go with it. And that's actually how they do it. Okay? So it doesn't require cooperation or thinking or anything like that. It's just a strictly physical movement. Now, of course, they know that there's a predator about, or they think they do. They're very skittish, by the way. The littlest thing can get them all riled up. Okay, so with the predator avoidance hypothesis, they're all in this group. Do you think it's difficult or easy to single out one individual in a group like that, that's flashing and all that, versus one by itself? Okay, so no. And it turns out that's true. So, oh yeah, let's say it was actually cooperative. So, would you do it with a bunch of close kin or not? That'd be one reason. Okay, these guys, of course, obviously they're not related because it's not only not the same, relatives, but also different species. Remember the zebra tail lizards from this weekend? When they run, they hold the tail up in the air. Why? Remember?
So it doesn't drag on
No?
the.
To warn us.
What?
Other stuff.
Defense against what?
And communication for other lizards.
Uh-huh, right. So it's like, go after my, or no, it's actually like it might be a signal.
Yeah, so the other ones.
Yeah, say, I already see you, so don't even try to chase me, you're just gonna waste your energy. Okay. Zebras, if you notice, have the same sort of coloring. They're also usually social animals. And there appears to be a predator avoidance thing with that. So, often what you do see when you see this behavior is you suddenly realize that there's a peregrine falcon or a merlin right in the midst of them. And they're all staying together in a cohesive unit, flashing and all that. The predator is actually, well, usually you think would get distracted, and actually does in a group. In fact, the whole hunting strategy of like a peregrine falcon is to get one individual away from the rest of the flock. The thing is, it's hard to get one individual because there's all this other signal coming in from other birds, but that's the idea. So, it actually is a predator avoidance hypothesis. In a way, it is a communication hypothesis. Well, what are they communicating about?
Danger.
Yeah, danger. And then there's that physical thing of staying in a flock. That's a form of communication as well. Migration, in fact, they do all get into a flock and migrate at the same time. The only difference is they don't show this kind of visual distortion that you would, in fact, most of the times they're actually flying at night, migrating at night. So, and then hunting, okay. Shorebirds, what do they think they eat?
Fish.
Fish? Okay.
Sand crabs.
Huh?
Sand crabs.
Sand crabs? How come they have all these different sized beaks?
To get different food.
Different food. Okay, so some of the food might be deeper, some more shallow. Some might be kind of in crags and rocks, in a tidal zone, that sort of thing. So, but when they're doing that, do you think they're flying around trying to catch stuff, or do you think when they actually try to eat something, they're sitting there and trying to forage? Yeah. So, they don't do it really for hunting. Mating. Well, they don't. They don't really do it for mating. Mostly what happens is, of course, the males display. They go through two different plumages. There's the basic plumage where they all kind of look the same. And then there's the alternate, what's called the alternate plumage, where the males get, all gussied up. And then it's a matter of mate choice and male-male competition going on. Interestingly, one of the shorebird groups actually, or a couple of them, do sex role reversal, where the female is actually competing for the male. So what she does is the males each make a nest, and the female, if she chooses them, she lays an egg or two in the nest. So she can have multiple nests going on at the same time. And there's a bunch of things. First of all, she can also store sperm. So although the males think it's their offspring, it doesn't necessarily be. A lot of times it's a surrogate. You know, and there's only one male that she knows this is a good male to do it with. So, okay. And of course the males, since they're the choosy ones, they're going to be putting parental care into the offspring, right? They have to, they're choosy. They don't want just some old egg in there. They want first grade. At the same time, the female is manipulating the males into thinking, you know, she gives them copulations, that sort of stuff, so everything's good. Until they do a paternity test. Which they do. In fact, that's how they found out.
I have a question about that.
Yeah.
So, you know how like in the book it talks about animals preferring to help their own relatives,
Mm-hmm.
right? So how do they know it's their own relative?
How do you know it's your own relative?
You grew up with them, or you're told.
Yeah, you grew up with them, right?
Right.
They're not like, you don't recognize them. In fact, you do.
Right.
Okay, so it's the same sort of thing.
But then like with, could be like a neighboring tree.
Yeah.
Like birds that they see pretty often. That
Yeah.
doesn't necessarily mean it's their relative.
Yeah.
Is there like something like?
So what they've established is that yes, they're aware that they're surrounded by relatives. The question is, how do they know that?
Okay, which one is relative? And
Yeah.
Which one isn't?
And you would think that it would be just growing up in certain circumstances, but there might be something else going on there, and I'm not sure what the mechanism is.
Because I was thinking, if there is something else going on,
Mm-hmm.
then why wouldn't the father know that the offspring isn't his
Mm-hmm.
in the situation that you just laid out?
Right. Yeah. Because perhaps when the eggs hatch and the chicks, maybe they don't smell right, something like that.
Right.
Apparently,
They're fooled.
they're fooled. Okay. Copulations do that with males. They think everything's all fine.
What was the bird again? What was this?
Okay,
bird
so
talking about? The one that does this, where the males are choosier.
Yeah. Phalaropes. A couple of different kinds. Okay. Okay, we went all through this previously. Hold on a second. Let me see something. Okay, there we go. Okay, hopefully I got all that other stuff. So, does mobbing behavior distract predators? Do you know what mobbing is? Okay. Okay, so that gets you the idea of what mobbing behavior is. Why are they mobbing the cranes? What are the cranes going to do? Yeah, steal their eggs. So, the question is, why are they doing it? So let's come up with some different hypotheses about perhaps why there's actually mobbing behavior. Hold on a second. Okay. Let's see. Okay, there we go.
Start over.
Yeah. Okay. So, so the benefit experienced, in other words, here we have probability that a crow will be subject to greater than 10 attacks by gulls per minute, and then this is percentage of successful predation attempts. So, when they're inside the colony, let's see, which is which? Oh, that's right. So the red is okay. The red is probability of the subject will be attacked. So inside the colony, there's greater attacks. Border, less so, and then outside the colony, not so much. And then percentage of successful predation attempts. So when they're outside the colony, there's more predators trying to do it. It's easier to go after the nest of one individual than the others all mobbing you. So there's support for this. And they get greater response to predators the closer they are to the colony, even though the colony is not made up of kin. You don't need that for this to happen. Okay. Oh, this is a different one. So there's a snake there. Why are they doing this? Why is it doing that?
To shoo it away.
He's trying to be aggressive or something.
Why doesn't he just run? I don't understand.
It's not really working.
Well, he's certainly kicking sand in his face.
Why doesn't he just run away like he does here on campus? I don't get it. They just.
So why don't they run away?
Yeah, I don't get it.
What is it? Did you say? Oh, anybody? Why don't they run away?
It's trying to protect something.
What are they protecting?
Young.
Young. Good. Okay. Hmm?
So wants to get eaten.
These guys. Wouldn't they get eaten? Yeah. It's a good question.
That's so sad.
Okay. So, now we know that mongooses harass cobras. In fact, they actually try to eat them. So there's two hypotheses. It might be that this squirrel is actually trying to eat the snake. And the other is that it's young.
Could be a third hypothesis.
There can be many. Any others?
I kind of often wonder if it could. I mean, obviously that's squirrel number 15, right?
Yeah.
So if they're observing several squirrels, right?
Yeah.
If they find out only 1 out of 100 is doing it, it could just be a thrill-seeking squirrel.
Mm-hmm. Okay. Or not necessarily thrilled. He just gets pissed off.
Which
You
is
know,
kind of like humans, right?
yeah.
Some humans like to swim with sharks. for
Oh yeah,
example,
that's
right?
true. But it's also, it's just that this guy pissed me off. Why is he here? I'm gonna,
Right, it's just like,
Yeah.
just not being the kind of the outsider of
Mhm.
the group. I think that's kind of the problem with when we do animal behavior is we assume that they all act
the same way.
the same way.
For the
but
sa-
there's-
yeah.
They're different individuals with different personalities, right?
That's true, absolutely. In fact, animal personalities is a big hot topic in behavior now. So, oftentimes what you do is you actually get, okay, enough.
So are the squirrels trying to bite the snake or just intimidate the snake? Because it doesn't
Oh,
seem
I
like
think
they're-
they probably could take nips if they can get a handle on it.
Okay.
They often do this when they have, they have all their young are underground in their burrows, and they kind of escort the snake away from the burrow. They'll still do it by themselves. Doesn't matter. But what usually happens is if one starts and finds a snake, everybody knows within a short period of time. Okay, so remember with the zebra tail, they hold the tail up. What kind of a signal? That's a pretty, visual signal, isn't it? Do you think it might ever be used to distract the predator? Like, go try to get me, and they go for the tail instead of the rest of the body, right? Well, all this tail movement they're doing, especially when they're dealing with you guys remember what a pit viper is? Rattlesnakes are pit vipers. What kind of information does it give them?
Sensory
Huh?
or heat?
Heat,
Heat.
exactly. It turns out that not only is the tail a big visual signal, but they can, while this is going on, blood supply is actually diverted to the tail to actually kind of make it hotter. So it's a distraction for the snake in terms of an actual target. And then finally, so we have ground squirrels all around here. You can find ground squirrels, different species, whatever, with in areas where there's no snakes versus areas where there are snakes. And they found that the adults are immune to snake bite. Like a dose that would really make you sick, land you in the hospital, nothing happens. They also found that in areas where there are no snakes, when they're dosed with, snake venom, they die. It also turns out that the young are up to a certain age are also susceptible to the venom. So pretty much these snakes are going after young. They can't go after adults because the venom really doesn't work. So you get this. Also, obviously, if there's no snakes around, how do you think individuals know that a snake is dangerous?
Individual squirrels?
Yeah. So, where there's no snakes around, would they recognize that a snake is dangerous, do you think? Versus when they're living in an area, they were born in an area where there's snakes, do you think they would recognize?
They may not.
They may not. So that would suggest what? Learning behavior, right? Now, I don't know exactly if it's true or not, but remember I talked to you about the monkeys and the snakes, and it's actually a combination of both. It might be that a snake is an inherited cue, but it's only turned on in a group where everybody's responding to it. So I'm not exactly sure what's going on, but that's the general gist of it. Okay, good. Okay, so in terms of hypotheses, like I said, we came up with 6 different ones for the shorebirds? Those are alternative hypotheses. So instead of just testing one hypothesis at a time against the null, which is, the null is there's no effect, essentially. So if it was not the predator hypothesis with the shorebirds, then they would do this behavior all the time, whether a predator is there or not. And versus with a predator, they might do it a lot because they're skittish, but they would more likely to do it when a predator is there. Okay, so one of the better ways to often do things like this is to come up with a whole bunch of alternatives that make different predictions. So when you were doing the stuff with the digger wasps, those in the field class, there were a whole bunch of different hypotheses. I think there were 3 of them, essentially. But you can come up with a whole bunch of hypotheses. So, of course, if we're an adaptationist, which is an individual who thinks that everything is adaptive in terms of evolution, then we formulate alternative hypotheses. They make predictions, we test them. Are different hypotheses and their predictions mutually exclusive? Not necessarily. So you can have both things happening, both causes operating at the same time. Okay. The way we finally find out, let's say, what is the best explanation is we try to refute it, in other words, falsifiable, and if we're not able to refute it, there's kind of conditional acceptance until new information comes along. So does that mean we should stop here? No, not really. Do we have an answer? We have a possible good answer, and it may hold up over time. Now the question is every explanation, every hypothesis adaptive? Can you think of a situation where it's not adaptive? Think about evolutionary history. In the past, the ancestor, this kind of behavior it was originally adapted for this response. What if this response is no longer around? I mean, the reason for it is no longer around. With the current species that make up this group, or taxa, would they all still do this behavior as a holdover from what happened in the past? So you have to make kind of distinctions. Sometimes it's just a result of it. Now, there could also be the same thing in the past was going on, the same thing in the future is going, and right now is going on, and there's current selection as well as what happened in the past. But a lot of there's a guy named Stephen Jay Gould. You might have heard of him. He's a paleontologist. He was kind of pissed off at everybody for saying everything was adaptive, and that if one adaptive hypothesis wasn't good, then you go immediately to another. So there was an archaeologist who worked in Mesoamerica, looked at the Aztecs. Now, the Aztecs, we're going to let you go, but the Aztecs, of course, made lots of sacrificial victims, right? And so there were questions about why they did this. And to make a long story short, this guy came up with the hypothesis that there wasn't enough meat. You know, so how do you get meat? You go find other groups of people and you butcher them. Yeah. It turns out, well, that really wasn't the reason they were doing it. It was a whole cosmological reason, you know. I mean, usually that's why you find, like, let's say one religion. But anyway, that's good for now. Oh, all taken care of.
Oh, it is?
Yeah. All we had to do is they'll watch it themselves. I take it over to, and we don't have to do it by our hand. We do it with a card.
Oh, okay.
Okay?
It says.
Yeah, that's done. Yeah. Yeah. So but we do have to watch all the. So I could call. What's that? What? Oh.
Thank you.
Oh, yeah.
Oh my god, there was one on her door last night. I flew in the house. I went the other way. It was right by my front door. I'm like, I'm not going this way.
Number 3.
Okay, so
Oh no.
this is kind of where we left off.
You could have just lied down once you get on top. You know, he even died down. I wish I had that.
Hi guys. Okay, this is kind of where we left off about alternative hypotheses, right? Some of them are adaptive, some of them are not. And not everyone is adaptive. So you can have something that's a trait that's not adaptive because it's a holdover from previous evolutionary history. In other words, a lineage has one type of behavior, but in a new environment, it may not be adaptive anymore. So you have to always consider that part of it. So phylogeny is kind of a constraint on evolution in a sense. In other words, pigs don't fly, and they don't fly for a reason. They're constrained in terms of selection acting on them to favor wings. So lineage is too constrained in terms of the way it develops to actually get wings. Now, I know that bats certainly develop wings. And so it's possible for a lineage of mammals to do that. Obviously, it's happened. But there's a lot of constraint in how organisms actually develop that makes them good at certain things, but not so good at others. It's a trade-off. And you guys know that trade-offs are kind of central to evolution. Okay, so anybody know what the comparative method is? What does comparative mean? You guys don't know what a comparison is? What?
To compare?
Yeah. You know what to compare, right?
Yeah.
Okay. Well, what the comparative method is looking at different lineages and trying to figure out what is a phylogenetic signal and what is actually a current adaptation. So we have a way, especially now, using DNA data and all that kind of stuff, and as well as behavior, anything you want to build a phylogeny with. If we have a decent phylogeny, we can actually make hypotheses about how things happened. And whether those things actually are the result of past evolutionary history or current adaptation. Now, at the same time, past evolutionary history, behaviors like that can still be adaptive. The same forces, selective forces that originated that sort of behavior might still be operating. So, we do want to know, so I asked, why might species share similar phenotypes? Well, there's two reasons. One is shared ancestry, and the other is shared selective environments or similar environments, right? So what's the name of this for this type of evolution where you have the same sorts of features, phenotypic features, in one group of organisms and in another, but they're not related? Convergent evolution, right. Okay. So, there are a couple of things that account for related species with different phenotypes. One is, so you have species that are related, but they have different phenotypes. In other words, there's divergent evolution there because there's different selective pressures that they're now confronting in new environments. There's also something called, what is it? Conservative niche. Oh, Christ. I forget. Anyway, where it kind of, you think of shorebirds. We saw those guys. They all look very similar. And almost all of them have the same sort of way of making a living. They eat crustaceans and things like that. They have different sized beaks for poking their beaks in the sand or picking things off of rocks along the seashore. All these different adaptations, but you're never going to actually see one hovering and trying to get nectar from a flower. So it's called phylogenetic niche conservatism. It's almost like a lineage is kind of stopped or prevented from branching out. They're good at one very good thing. They're very good at that, but they really aren't, because of that optimality in that sort of situation, they're really not capable of branching out into new niches. Everybody understand that? Just want to make sure. So, in terms of, now also, there's this question of where are you more likely to find body size as an important factor in where they nest? Like what might constrain body size? So, if you're on the ground, does it matter whether you have a big body or a small body? No. But if you're on a cliff, where might being small or large be better? Be better to be small. Your obviously space is at a minimum, and you want to utilize that as effectively as possible, especially when the chicks start growing up at the size of almost full-size adults, and they're not exactly, as good at staying in one place as adults. So, you would probably find colonial or cooperative behavior in ground nesting species where they all nest together. And you would also figure that in terms of body size, you'd have smaller species on cliffs. Now, and you would also predict that you wouldn't have any sort of mobbing behavior. You don't really need it on a cliff. Individuals, there are only so many spaces they can put nests. It doesn't mean they can put them all together. And so the criteria or the selection that would require that you need for mobbing efficiently isn't really met on a cliff. So, in terms of cliff nesting gulls, we would make predictions, obviously, about what kind of behaviors they have, how they would live, all that might be different from what you would figure out on the ground. Here, let's take a look. Okay. So, obviously, not all these birds nest on the ground. These are little kittiwakes. Let's see, there's some guillemots there as well as some kittiwakes. These are shorebirds and whatnot. Now, okay, so here we have a comparison, let's say, between rough-winged and other solitary nesting swallows and bank swallows, which are colonial. So, if you remember, on the trip, we went to the bat cave. And inside the bat cave, in addition to, there was, I think, one bat, swallows also have a kind of a small colonial nest sometimes. So they make these daub mud houses, and they all nest together in that specific area. And it was probably, it wasn't bank swallows, it was either barn swallows or cliff swallows, probably cliff swallows. Okay, so you would have similar selective pressures, right, for colonial swallows as you would for ground nesting gulls. Convergent evolution, in other words, they're not related by lineage, but they get to the same place in terms of evolution by having similar environments, which actually favor the same sort of behavior. And then, of course, here we have divergent evolution, shared ancestry, but different behavior. So if we were going to, let's say we didn't know anything about any of this, that, you know, we've got swallows here and gulls here, and all we had was behavior in terms of cliff nesting and being solitary and solitary, or being colonial and colonial. If that was the only criteria, now we never want to build a phylogeny on one trait. We want as many traits as possible because, remember about homoplasy, convergent evolution kind of messes things up in terms of inferring phylogenetic history. But if that was all we had, we actually might, I think I'll put something in here. Okay. Okay, let's see what we got here. How am I going to do this? Okay. If it was just solitary versus colonial, we might put, here's solitary, here's colonial. We might put the bank swallow and the kittiwake here, and colonial gulls, like the black-headed gull, and cliff swallows here. Now, this would be a completely inappropriate, it wouldn't be a real phylogeny. All we'd have to do is pretty much look at it, or look at the animals that we're talking about, and realize, well, this doesn't really go together. Okay? But that's why you want to use as many characters as possible in terms of inferring phylogeny, because if there's any homoplasia there, the more characters will drown it out. So you might have a couple of instances where there's convergent evolution, but it'll show you that, in fact, that's actually what it is and not phylogenetic history. It's kind of like, you probably remember about the phylogeny of whales and cetaceans and artiodactyls. And, of course, when classifying artiodactyls, they used morphological, like this pulley system in the ankle. Well, whales don't have ankles, obviously. They still have, obviously, they have pelvic girdles and buds for the various limbs, but they lost those. So instead, what they did when they finally inferred proper phylogenetically, they used a bunch of SNPs, which are single nucleotide repeats, that are shared with artiodactyls and whales because they shared an evolutionary history. And so the fact that an astragalus was not in a whale was pretty much meaningless as a unique character trait for artiodactyls. Okay. So the ability to hear ultrasound in one species of moth, it is considered an anti-predator adaptation because it enables individuals to hear and avoid nocturnal ultrasound using bats. So, it's like radar. The ultrasound enables the bats, of course, to find the moths, but the moths also can use that signal to detect that, oh, there's a bat around, I have to take evasive action. Now, if there's a bunch of different noctuid moths, many different species, if they all face the same selective pressure, namely bat predation, you'd expect that all of them would be able to hear ultrasound using bats and take evasive action. So imagine you wish to test this hypothesis via the comparative method. You would identify the utility of each of the following lines of evidence on hearing abilities in other insect species. Specify whether these cases involve convergent evolution, divergent evolution, or neither. And, okay. Almost all other species of noctuid moths also have ears that respond to ultrasound. So, would you consider that independent evolution or phylogenetic history? Okay, phylogenetic history. Almost all the species in the evolutionary lineage that includes the noctuid moths and several other groups also have ears that respond to ultrasound. Right. Some diurnal noctuid moths have ears but are largely or totally incapable of hearing ultrasound. Mm-hmm. Almost all butterflies, which belong to the same large evolutionary grouping as noctuids, are usually active during the day and they lack ears to detect ultrasound. Huh?
Divergent?
Okay, what about all the butterflies, though, as a lineage? Do you think they share the most recent common ancestor, and so they now all have dysfunctional ears? Along with that, some of those diurnal noctuids, perhaps they share an evolutionary history with those as well. So there was an ancestor out of this whole group of nocturnal species that used the daylight niche. Being able to hear ultrasound is no longer adaptive. And so that selection, kind of relaxed selection, you didn't need it anymore. Okay.
So what is it?
It's phylogenetic history, I would say. Obviously, the ancestor to the diurnal noctuids and the butterflies, that was divergent selection from the larger group of nocturnal moths and butterflies, that whole lineage.
So it'd be both.
What?
So it'd be
In a sense, it's both, but this is pretty much almost all butterflies, which belong to the same evolutionary grouping, are active during the day. So you're inferring that. Is that me? Oh, okay. Yeah, I'll get it later. Okay. Stop it. Okay, I got it.
Community service?
There. Now, so 6 species of noctuid moths found only on the Pacific Ocean islands of Tahiti and Moorea have ears and can hear ultrasound but do not react to the stimulus with anti-bat responses, such as diving for cover.
divergent.
Mm-hmm. Members of one small group of nocturnal butterflies have ears on their wings and can hear ultrasound. They respond to ultrasonic stimulation by engaging in unpredictable dives, loops, and spirals. Well, it's divergent evolution for that group. Okay? So it's kind of like the previous one. On this group of islands, we said divergent evolution because actually, let's see. Yeah. Divergent evolution. And this is one small group that have ears on their wings and do respond. Okay, but they're only. So this is actually, it's not divergent, it's actually convergent evolution. Sorry.
Why is it convergent?
Because, okay, let's see. Most butterflies are diurnal. Okay, now, the moths, which are nocturnal, that's a different selective environment. When you end up with the same sort of morphology and anatomy and behavior in lineages that are, in a sense, in the larger sense, they're all related to each other, but in a more restricted sense, they're not. It's convergent evolution. Lacewings and praying mantises fly at night and have ears that detect ultrasound and lead to anti-bat defensive behavior. Convergent, yeah. Okay. So there's these weaver birds in Africa. They build these magnificent pendulous nests, different species. They have huge flocks and huge colonies all living together. They don't necessarily cooperate with each other. They don't. But they're found in big colonies all flocking together. So you can make up a couple of scenarios, kind of just so stories. You guys remember the just so stories from, who's that writer? Come on. Mobley, English. Oh, for Christ's sakes. Kipling. Kipling came up with a bunch of just so stories. And as I mentioned previously, with Dr. Pangloss and Gould, and a lot of evolutionary biologists came up with just so stories too, that sounded plausible explanations for how evolution happened. One of the most famous cases was an archaeologist who suggested that the Aztecs actually practiced ritual, mass ritual slaughter because there was actually a short supply of meat. It's possible. So all these others that weren't related to them, they got the axe, so to speak. So now that doesn't sound really plausible, but archaeologists, what can you expect from them? Okay. Actually, I know some good archaeologists, but so just so stories are basically hypotheses, plausible explanations, but it doesn't make them so. You actually need predictions and data to show that that's in fact what's going on. So, diet caused by social living. Patchy seed distribution, easier to find seeds in a group foraging species, so if one member finds some seeds, all the others are there. You could also say dense seed distribution, where it would a very productive patch of seeds would permit a large group to forage successfully without having to leave it too soon. It's okay. So the thing is, predators cause social living instead of diet. So group living is a good anti-predator strategy. Seeds may be the only diet to support large groups. So the seeds might in fact be a byproduct of needing to avoid predators. Now, how would being social living be adaptive in this environment? So this is a whole bunch of them. These are all individual birds. What do you think? Remember when we looked at the Humboldt Bay birds and they were all flocking together like that? Okay, so is it difficult to pick out one individual from this thing versus a lot, versus single? Okay. One of the hypotheses is that it's called the dilution effect. In other words, there's so many opportunities to get it right that it confuses the predator and they can't really focus on any one individual. So, what is the cause and what is the effect? These are correlated. In other words, the seed business and anti-predator thing are correlated with each other, yeah.
Could they be mimicking the trees? I mean, because like from here it looks like they're just a bunch of leaves.
Yeah, I mean, if you think about also the shorebirds that were flocking, it's like there's definitely a visual confusion aspect there in terms of mimicking length. In this case, okay, they may be mimicking the leaves or the brown grass or whatever, so they blend in. So, why do Pogonomyrmex ants mate in a group? Same sort of thing. So, these ants actually, at a certain time, they fly when they're mating, and they all get up in a big group. Now, when they're mating, they're kind of oblivious to other things that might be going on, namely like a dragonfly that's coming along. But if there's a lot of different targets, the chance that any one individual will get taken is much reduced compared to if they were perhaps off by themselves. Of course, you could also say that, well, these guys wouldn't be around if they were off by themselves. It wouldn't be a very good patch to pick off ants, would it? They're going to pretty much concentrate on areas where there's lots of ants flying. So, see, I'm going back and forth. You have to think about all these things at the same time. So here's the dilution effect. Predation risk, group size, it's very high when it's low, and it goes much lower. For each individual, the bigger the group size. So, same thing here, percent eaten. When they start hatching, there's only a few, and a predator, they know they're hatching, so they're going to sit there and wait and pick them off individually. But as they start emerging in greater numbers until finally, let's say 200 a day or whatever, there's so many emerging that it's impossible to actually focus on, let's say, any one individual. So this is kind of a classic dilution effect in terms of an anti-predator behavior. By the way, these butterflies don't necessarily look like, since they're kind of on the mud here, they don't look like they're actually trying to be camouflaged, do they? So, yeah. I would say that someone gave them a bum steer. Why do you think they might be colorful like this? Any other selective pressure that might favor that?
Poisonous maybe?
Huh?
Poisonous maybe?
Perhaps they're, aposematic. Anything else?
Mimicking something else
Huh?
Mimicking something else that's poisonous?
Okay.
Isn't it called Batesian or?
Batesian and
Yeah,
Mullerian.
something,
Okay, so
yeah.
Batesian is a non-toxic species mimicking a toxic species that's in the same area. So the model, which is a toxic one, the only way it's going to work is if the mimic is in lower percentage or lower frequency than the actual model. In other words, if it went up and to the point where it was, let's say, more frequent than the model, then there's a good chance the predator might still go after it, because the chances of, let's say, instead of it being, 1 in 10 are suddenly 50-50, and that they're likely to get a non-toxic meal. Okay. What about mating? Perhaps butterflies use bright colors for mating as well. Okay. Oh, poor Johnny. So, this is a leopard seal. That's poor Johnny, ripped to shreds. These other guys are going, well, while he's occupied, let's jump in and better him than me. So this is what's called the selfish herd. Now, what's the difference between a selfish herd and a dilution effect? Is there any? Remember, dilution effect is just there's many different targets. If you were in a herd and you were being selfish, where would you position yourself?
Far from the predator.
Have someone else between you and them. So perhaps inside the herd and not on the edges. Okay. Poor Johnny was on the edges. He jumped in first. It bit him in the ass, in a sense. Okay. Now, in addition, there's another part of being a herd. There's another advantage, and that's improved or shared vigilance. So if you have many eyes, looking for predators, instead of just you, you're more likely to be safe in a group. Because then if you see something, other member is going to react to what you do. So let's see, are these? No, these aren't meerkats. No, they're a ground squirrel. No, they're prairie dogs. That's what they are. Now, the shared vigilance, just on its own, is a strong enough adaptive pressure that you gain some benefits from it. But of course, if you start throwing in things like kin selection, then you even get more because of inclusive fitness. And so here we are again with like the mobbing behavior, communal defense. Let's see. So these are, I think, royal terns, colonial nesters. Here's a gull that's come along and is trying to steal an egg. They don't look very successful. They just look like they're yakking a lot. These are colonial wasps. You can imagine, well, let me actually, I think I have a video on this somewhere. What?
What kind of birds are A? The ones in A?
Oh, those are royal terns on the right. And that looks like some kind of a gull. I'm not sure, a juvenile gull on the left. Okay.
Yeah, for Halloween it's like down. I'll call it. Oh yeah, that's right.
Now come pouring out, and
What are those?
they're wasps.
Oh. Yeah. Where's the fire marshal?
Yeah.
That's over capacity.
God, enough already.
Seriously. Fire hazard. That's a fire hazard.
Okay. I think there's oh.
the kingfisher. Yep.
Okay, you get the idea.
Yeah, I did. Try it again.
That's lousy reading.
What does it look like inside?
Oh, I don't know, I haven't been there.
Better you than me.
Yeah, okay. Oh, camouflage, good. Okay. Let's see here. Okay, we'll read this. So, not working? I put new batteries in it. Okay. So, this kind of mimicry, cryptic behavior, obviously, it depends on where you choose to rest. So, here's a horned lizard that we didn't see. Kind of stands out. But here, it's also here as well, and you can't see it. This is the old peppered moth from time immemorial. So initially, before the industrial age in Great Britain, the bark was white. There's two different forms. There's the light form and the melanistic form. It's a polymorphism that's maintained. In this environment, this form is much less common, as you'd expect. But after coal dust and all that, then this light form stands out, and in fact, this form is favored. Okay, so this kind of morphology, in a sense, is costly to produce, perhaps. And then you have to also figure in other things like getting on the right kind of background, that sort of thing. Now, of course, if you're an octopus or a cuttlefish that can change the colors and the patterns of all your skin, then you can pretty much blend in anywhere you are, because you can mimic that sort of background. Of course, survival, that's the benefits. Now, do predators use this as well? Right? So you're mimicking your background so they don't see you. In fact, for those of you who were on the trip, what reptile did we see that used this sort of mimicry, this sort of camouflage?
Was it the lizard?
What?
The lizard?
The lizard. That
Or the
was at
snake?
Kelso. Sand dunes.
The snake.
The snake.
Yeah. So the snake is okay. Some of the lizards that we saw are active foragers, and others are sit and wait. The snake was definitely a sit and wait. That was the sidewinder rattler, right? So it blends in with the background. It's very hard to actually see the snake. The snake doesn't want to even move for the most part. They get on a scent trail and they sit there and wait for the animal eventually to come along. Okay, so here's the moth again, and you can see the typical. That's right, I can't do that. The typical, which is the light colored, versus the melanic, which is this group, and the typical is on the trunk. The melanic, let's see, no, let's see, the melanic, okay, got you. Polluted woodland, oh, that's why, okay, right. So, the polluted, they're both on the trunk, but obviously the melanic does better in a polluted woodland. And then non-polluted woodland, let's see, the typical is about the same. And then the melanic is, God, I don't know, oh, predation, let's see what it says here. There we go. Okay, number eaten of 50 presented. Okay, right, so this is actually showing the ones that are getting eaten. So polluted woodland, there's more, the ones that are on the trunk show up better. The melanic have lower numbers getting eaten. Non-polluted woodland is kind of the opposite. The melanic stand out and all get eaten. I'm going to go over to here better. It's not working. Okay. So here we are with all that. Okay. Where is the other one? Oh, hold on. Here we go. Okay. So, I used poison dart frog, I just felt like it. So, obviously, the color, if you're actually toxic, it's usually expensive to make a toxin. Of course, what was it? I think there's another example, scent. There's a type of firefly that the males blink. No, the females blink and the males come in, right? And there's also another species of firefly, and the female in that does the same business as the model, but when she comes upon a male, she eats him. Okay? So there's a mimic in terms of the blinking and the scent that brings the male in to, of course, death. But that happens anyway all the time, so it doesn't matter. Okay, so why are some animals conspicuous? It's called aposematic coloration. Obviously, it's costly because you're trying to be bright and colorful. Oh shoot, hold on a second. And we'll start where we kind of left off. Let's see, when is the next test?
Oh, when is the test?
The exam?
Yeah.
You had it October 12th on Moodle, but that's a Sunday.
The Sunday?
Yeah.
That's a good time for it.
Yeah.
Let's see here.
Maybe we should push it back like.
Can you push it back another week?
Yeah, maybe we should do it that Wednesday.
Well, let me just let's look at it.
That's right.
Okay, so God, really? I put it at no, it's not October 12th.
You did.
Okay, so see, I'm thinking that once we're done with this section on predation, which will be probably Monday. that maybe we'll have it the following Wednesday. I mean, not Wednesday. That's next Wednesday, a week from today.
So can you give us the 15th?
Do you want it on the 8th?
Yeah, is that too soon?
Can you make it the 22nd?
Yeah, maybe 15.
22nd? I'm good with 15.
Okay, I'll, so we're gonna move it, right?
Yeah, can we move it to
Okay,
the 22nd?
yeah,
Please.
okay, let's see, where's,
Because I have a genetics exam too, and they're the same day.
22nd.
22nd.
just hold on a second.
We made a vote.
Okay,
Have it as the 15th already.
So yeah, 22nd.
Oh, perfect.
okay, yeah, no, it's gonna be the 15th. Yeah, no, it's just, that's too long. We'll see, I'll tell you what, we'll see what, I think the next section is communication. Kind of, we've been actually, predation has to do with communication too, obviously. Either hiding things or revealing things. So, we'll see how far we get with that. And then, no, we'll do it the 15th, and then we'll just go up through chapter 5, this predation thing, and then the next thing will be the final. Okay?
So it's probably chapter 1 to 5 for exam 1.
It's not, no, it's just the stuff that we've covered. So we haven't, you can read one, there's not much there. There's some. I have a study guide out for you, so just follow that.
Is it multiple choice or
What?
the exam?
No, no. It's going to be 10 multiple choice, 1 point each. Short answer, 5 points, 13 of them. And then a 25-point essay.
So do we need to bring the Scantron with the essay portion on it?
What did I do?
Graded the exam?
I think I, what?
Are you grading the exam? Or
I and Andrea, we're gonna split it up. So
Can
she'll
you grade
do,
mine?
she'll do,
Can you grade mine?
no. She's gonna do one part of it. I'm gonna do other parts of it. Oh, so it's not like there's variability. We don't want that. We want to control for,
so she'll do like multiple choice.
Yeah.
Can you do the essay?
Can she do the multiple
oh,
choice?
I'm doing the essay.
Okay, good.
Okay. The multiple choice, I think, yeah, bring a Scantron for that. Yeah.
Really, for 10 questions though?
No, and I think you'll probably, let me look at it. I forget what we did last time. But anyway, I'll let you know. Okay?
From my trip.
For those students in field studies, we're going on a field trip on Monday.
Yeah, I'll get back to you on that. I've talked about getting the vans.
How about the field studies?
What about it?
We're doing Malibu next week.
Yeah, let me get back to you on that as far as whether whether I can get the vans. I haven't actually, so I'll let you know right away. Okay, is there a problem with the next Monday?
No, I thought we're leaving next Monday.
Yeah, we just want to know what's going on.
Yeah, I'm planning on it. Hopefully I think I can get the vans on Monday because usually they're in the
Where are we
week
going
event.
exactly?
Malibu,
Malibu. We're going to the beach. Just
Should
the
we
beach.
print something out?
Lagoon.
Should we print something out?
Yeah, we're gonna have I'll send you an email with everything on it.
Great.
Okay?
Thank you.
Awesome.
Good.
Are you going to